Hello, welcome to the video notes for lesson 3.3. This lesson is all about functions. This begins on page 12 from your notes packet. You should see the same picture on the screen that you have on your paper. So let's go ahead and get started. We'll start with the target. I can determine if a relation is a function. So we're going to be talking about what a function is and how you can tell if you have one or if it's not a function. So we have a lot of terms and definitions, so I'll be talking about all those things. It's important for you to get to know them and remember them. Alright? And we'll do a lot of strategies in math to help some of you remember these. So, first thing. These little curly brackets here are what we use for what's called set notation. Okay? And what we say is the set of. So we've got a whole bunch of points here. So what we call this is the set of ordered pairs or coordinate pairs. Ordered pairs or coordinate pairs. Because these are the coordinates for different points on a graph. So you'll notice inside the curly brackets we have parentheses, and inside the parentheses we've got the two numbers, the x and the y values. Okay? So any set of ordered pairs is called a relation. So this right here is a relation. It's a set of ordered pairs. We have 1, 2, 3, 4, 5 points in this set of ordered pairs. Alright? Simple enough so far. Next thing, we have here a table. And you'll notice that in the table we have some values that are listed. Some are listed under the input values, and then we have some under the output. You'll also notice, I don't like this that's already above there. This is our x values, this is our y values. So from now on you might hear, instead of x and y, input and output. So the input values are the x coordinates, output values are the y coordinates. Very important for you to remember that. Alright, below that we have what's called a mapping diagram. This is not a table. It looks kind of like a table, and sometimes we get the values from a table, but it's not a table. Basically it's a list of values. A list of values, and then notice what they're connected by. A list of values connected with arrows. And this is one of the tools used to help identify if something is a function. So a mapping diagram describes a relationship by linking the input values with the corresponding output values using arrows. So whenever I ask you what do we use in our mapping diagrams to help connect the values, I expect you to say arrows. Alright? Okay, so far so good. Let's go ahead and take a look at the next page. Page 13. So, this is how you make a mapping diagram. So if I give you a set of ordered pairs, or points, what you do is you list all the x values, or all the input values, and put something around them, so that you can keep them separated from the y values, or the output values. Okay, so I'll list them. So I have -2, -1, 0, and 1. So those are listed. And then I list the y values over alongside of them. Notice that there are two 1s, but I only put one over here. You don't continue to list repeats. Now, remember what we connect them with? We connect them with arrows. Okay, big idea here. How many outputs does each input have? So this input, -2, has one output. -1, one output. 0 has one output, and 1 has one output. So every input has one output. Because that's true, this is a function. So we're going to talk about the definition of this in just a minute, what a function is. Because this has one, every input has one output, it is a function. So let's take a look at this next one here. So again, I'm going to list my x values. So I have 0, 1, 2, and 3. So go ahead and put an oval around them. And then alongside of them, vertically, I'm going to list the y values. So I have 1, 2, 3, and then I have 2 again, but since I already have 2 in this list, I don't have to write it again. Now, connect these with arrows. So 0 goes to 1, 1 goes to 2, 2 goes to 3, and 3 goes to 2. It's okay if the arrows cross over like that. There's no rule against that. Here's what's important. Every input has exactly one output. 0 has 1, 1 has 2, 2 has 3, 3 has 2. So, because of this, this is a function. This is a function. Okay? Okay, so let's take a look at the last example. Again, we're going to make a mapping diagram. We have our set of ordered pairs. We're going to list all our x values first. So we have 1, there's 2 1s, and we have 4. That's it. Those are all the x, or input values. Then our y, or output values, are -1, 1, 2, and -2. None of these repeat, so I just list them all. Now let's connect them with arrows. So 1 goes to -1, and 1 goes to +1. 4 goes to 2, and to -2. Okay, what does that mean? Well, how many outputs does each input have? 1 and 4 have 2 outputs, or more than one. Have 2 outputs. So what does that mean? That means this is not a function. This is not a function. Alright, so why is that? Well, let's take a look at the rule about functions. Over on page 14. Big definition here. We're going to be saying this. We're going to be writing this. We're going to be remembering this, because this is huge. A function is a rule for taking each input value and producing exactly one output value. So, a relation is a function if each input has exactly one output. You're going to be asked to identify if something is a function or not, and then explain. If it is a function, this is the statement you're going to say. It is a function because each input has exactly one output. If it's not a function, then you're going to say, well, it's not because of what we just said. Alright, so, here are the same examples from the other page. So, over here we have, this is a function. And if I asked you on a test or some other assessment to explain why it's a function, you would say, well, looking at my mapping diagram here, this is a function because each input has exactly one output. So yes, I want you to write that down right now. Each input has exactly one output. Okay, over here, this is not a function. Well, follow the arrows. 1, the input, has an output of -1, and it has an output of 1. So, 1 and 4 have more than one output. So, if I give you a table of values, or if I give you a set of ordered pairs, and you're asked to tell if it's a function, you might create a mapping diagram, and then identify if each input has exactly one output, it is a function. If any of the inputs have more than one, it is not a function. Now, if I give you a graph and ask you to do something, or to tell if it's a function, you can use something known as the vertical line test. Okay, first of all, what's a vertical line? It's a line that goes like this, up and down. So if you were to look at a graph, and if you have a line, or if you have a bunch of points, and then you draw vertical lines through the points or whatever you have graphed, if the vertical line, if any of these vertical lines only go through one point, it is a function. So each line goes through one point only. Now over here, the second example, you'll notice here are the points. The vertical lines go through more than one point. So this is not a function. This one is a function. And this one is not because the lines go through more than one point. The vertical lines go through more than one point. And I realize this video is starting to get long, so I'm going to try to speed it up a little bit. Okay, so let's figure this out. Basically, the vertical line test is kind of like restating the same thing from up above. If it goes through only one point, then that's the same as saying each input has exactly one output. If it goes through more than one point, then that's the same thing as saying that there are inputs that have more than one output. Okay? Not a function is a function. This one passed the vertical line test. This one failed the vertical line test. Okay. Over on the next page, I'm just going to get you started on a couple more examples, and then we're going to stop. Okay, which relation and its graph is a function? Explain. Okay, so I want you to try to tell me, looking at the graph, so we have the table, and then they're plotted, so we've got 0, 0. So you'll see this is the graph that goes with this table, and this graph goes with this table. I want you to at least figure out which one is a function and which one is not. Okay? Same thing with the set of ordered pairs below. There is one of these is a function and one of these is not. At least determine which one is and which one is not. And if you can, I'd be really impressed if anybody can come up with the proper explanation for it. But we will do that in math one way, together, just to make sure. All right, one last thing before I wrap up this video. Going all the way back to the beginning. Well, actually, looking here on page 14, there's a definition on page 14, and there are 4 definitions on page 12. That means a total of 5. If 5 different people can restate these 5 different definitions, then that'll be a 1 point each for a total of 5 points on your scoreboard without looking. So your binder will need to be closed, and without telling anybody else what it is that you're up to. So I want to see if people can figure out what's going on, all right? So that's how you can earn another 5 points on your scoreboard, by remembering and restating these definitions out loud in math, all right? If you have any questions, make sure you come see me or get help from a friend or a parent. Good luck, and we'll see you in math.